In this video, we're going to take a look at an individual integral here. It's going to be a basic u-substitution integral. So we're going to start by letting our u be that square root of x. So u equals square root of x. Now, I'm going to want to think of that as an x to the 1/2 power. It's going to be easier when I take the derivative. So I'm going to take the derivative of both sides. We'll have a du is equal to, taking the derivative there, we'll have a 1/2 x to the negative 1/2, and then dx. All right, I'm going to go ahead and move this to the bottom and turn it into a square root. So we'll have a du is equal to a 1 over 2 square root of x dx. Now I'm going to want to go ahead and solve all the way down for my dx. So we'll multiply both sides by that 2 square root of x. So 2 square root of x du is equal to dx. All right, now from there, we'll come right back up here and we'll start doing our u substitutions, what we can do here. Now, I am going to remove the 1 and 9 because the 1 and 9 are limits of integration for x, because this function is in terms of x. As soon as I start substituting and have u values in here, I no longer have a function that is fully in terms of x. So that's why I need to remove the 1 and the 9. So we'll have an integral here without the 1 and the 9. We're going to replace that square root of x with a u. So we'll have an e to the u. We'll still have the square root of x there on the bottom. All right, we're going to replace dx with what it equals, which is a 2 square root of x. All right, and then du. All right, what that's going to allow me to do then is to take that square root of x and square root of x and cross them out. All right, I have a constant here of 2, which I can pull out in front of the integral. So we'll have a 2 integral of an e to the u du. All right, but again, this whole process, I now have a function in terms of u, so that 1 and 9, which are limits of integration for x, cannot be written at this part right here because I now have a function in terms of u. All right, I'm going to go ahead and integrate this. So when I integrate e to the u, I will get an e to the u. So we'll have a 2e to the u. All right, and then we can put the plus c on there if you want. You've integrated at that point. Now, I want to go ahead and replace this with what my u equals to put it back in terms of an x function. Once I put it back in terms of an x function, then I can reintroduce the 1 and the 9. So I'm going to have a 2e to the square root of x, and then 1 and 9, because these are limits of integration for x. I now have a function completely in terms of x. All right. Now, we can, to make the math a little bit easier here, we can think of it as this is boxed off. We pulled that 2 out in front. Go ahead and be consistent with those brackets there. All right. It'll just make the direct substitution here, the 1 and the 9, a little bit easier. So then I'm going to have a 2. I'm going to plug in my 9. So I'm going to have e to the square root of 9, all right, and then minus e to the square root of 1. All right, square root of 9 is a 3, so then that's going to give me a 2e to the 3rd power. This will be just an e minus e. So a pretty straightforward there. I think the number one thing I'm trying to get at here is these are limits of integration for x. When you start working this problem out in terms of u, if you're not going to change these to limits of integration for u, then just drop them off. Don't put them in. When you go back to a function in terms of x, then you can reintroduce them. All right, there is a way to change these limits of integration from x to limits of integration for u. All right, but that's not what I was demonstrating in this video. So basically a straightforward u substitution integral that would probably be typically found in a Calc 1 class. Definitely thanks for watching. If the videos are helping, please share with your friends so they can benefit too. And don't forget to subscribe to the channel. Thanks.